Now in this problem, we basically can do two operations. So one is we can select a prefix and we can decrement one from all the elements of that particular prefix, and the other operation being that we can set any of the element to zero. Now we have to find the minimum number of ways in which we can turn all the elements to zero. Right? So this is what the problem is. Now, in order to solve this problem, you first need to realize the power of the first operation. So let's just say I have some two number of threes and then some five number of twos and then some two ones. Right now, if I just take all the elements as the prefix and then apply the first operation for three number of times, there is I just applying the first operation for three number of times. Right. In that case, all the elements would have become zero. Right. So with just three number of operations, I have made all these elements as zero. So that's the power of the first operation. So how many elements are there? So it's 1, 2, 3, 4, 5, 6, 7, 8. So I can make all the 8 elements and we can convert them to zero in just three number of operations. So that's how powerful the first operation is. So in order to solve this problem, we'll be using as much as first operations as possible. When we take some element, let's say 4, all the elements that are greater than 4, which occur to the right hand side of 4, will be made invalid in the sense. So if I have something like 4, 5, and then 6, this 5 and 6 will be losing its significance, because if you do some number of operations and make the first element, there is 4 as 0. So if I apply 4 number of operations, then in the last it will be converted to 0, 1, 2. Right. So this particular element would have become 0, but these elements to the right hand side will not have become 0. Right, even after performing 4 number of operations. All the elements that are greater than this 4, which occur to the right hand side of this 4, should be made to 0 just by using the second operation. So only if we apply the second operation for these two elements, then we can convert it to 0. So if there is an element x and there are some elements that are greater than or equals to x to the right hand side of it, then all these elements can only be converted to 0 with the second operation. This is the basic idea behind this problem. So at first I'll be trying to accumulate the elements such that whenever I take one element, all the elements that are greater than that particular element to the right hand side are neglected. Now let's take an example. So let's say we have 9 elements and these are the elements of the array. So let me construct a new array with no invalid elements. So I'm just taking 7 over here. So if at all there are elements that are greater than 7 to the right hand side, then I'll be just neglecting them. Right. Now the next element is 3. So as I have taken 3, I'll be just looking to the right hand side, and as I have greater elements, there is 5 and 6 over here. So they'll be invalidated in the sense when I take when I do 3 number of operations till here, then this particular value would have become 0. And if you notice over here, even these values have a chance of becoming 0 if I do 3 number of moves. But these two numbers would not have become 0, and I have to do the second operation for 2 number of times. So I don't want any of those values. I just want the values which could become 0 when I do 3 number of moves. Right. So these two values would have become invalidated. Now let me just go to the next element, which is 2. Right. So if I take 2, then all the elements that are greater than 2 should be invalidated. That is, I can invalidate this 3 over here now. Now let me go to the next value, which is again 2. So I'll be just appending it to the new one array which I'm creating. Also, I'll be appending 1 and 1 over here. So these are the different operations, or these are the different values to which I can utilize the first operation. That is, I can utilize the power of the first operation as much as possible with these elements. So the thing is, if I try to eradicate this 3, that is, if I do 3 number of operations, all the elements that are written over here will be becoming 0. So what I'm trying to say is, this 3 is nothing but it comes from here, right? So if I do 3 number of operations, all the elements that I have written over here, this 3, this 2, and this 2, this 1 and this 1. These elements would have become 0, right? So that for these number of elements, I will not be doing any second operation again. And only for the other operations or other elements that are left out, I'll be utilizing the second operation. How to calculate the minimum answer for this? I'll be trying to compute the answer from the last if you take the first element, then the value is 1, which means that at least I have to do one number of first operation to eradicate or make it into 0. Now, I'll be just taking till this part. Now, for all the elements, I'll be utilizing the second operation. So, there are totally 9 number of elements, and I just took one element over here. So, the total number of operations is 9. Now, we just take till the second index in the last. So, in that sense, it will be just one number of moves to make all these elements to 0. Now, 9 minus, as we have entered 2 elements, we'll be putting a 2 over here. So, other than these 2 elements, all the other 7 elements need an additional second operation to convert it into zeros. So, the answer will be 8 as of now. Now, if I include this 2, then the number of operations that are done will be 2. That is, the first operation will be 2. And then I'm including 3 number of elements till this point. Right. Now, if I include this 2, then it will be like, in order to make all the elements till this point will be 2, and the number of elements that I included is 4. So I can make all the operations, or I can convert all the elements to zeros in some number of operations. Now, if I continue the same operation, then it will go something like this. So 7 will be the least number of operations in which we can convert all the elements to 7. And how is that possible? So if I reach out till the 4th index, it is till here, if I do the first operation, and for other elements, if I do the second operation, then I can achieve it in 7 moves. So is it valid? Yeah, because if I do 2 number of operations, then till here everything would have become 0. There is still this 2. So this 2, and these 2 ones would have become 0. So 4 elements are out. So 9 minus 4 is 5. So all of the 5 elements need an additional operation. So 2 plus 5 is 7. Yeah. So the ideation is very simple. At first, I'm just accumulating all the elements that are valid. Whenever I go to an element, I'll be just erasing all the elements that are greater than that particular element to the right hand side. So if I take this 3, then I won't be considering this 5 and 6. Right. So this array that we are constructing will always be in a non-increasing order. That is decreasing or equals to each other. Right. So with this array, I'll be just traversing it from the last. So for these number of times, I'll be conducting the first operation, and for the remaining elements, I'll be conducting the second operation. By this, we can minimize the answer that is obtained at the last. Now let me just quickly show the code for this. Now at first, I'll be taking the input for the elements as such, and for the minimum value, I'll be just keeping a variable, and the initial value will be just the first element of the array or the vector. Right. Now, the basic funda is that I'll be grouping all the elements that are valid. So if there is a value x, then all the elements that are greater than this particular value of x, which occur to the right hand side of it, should be eliminated. So the other way to think about is, I can just include the elements which are less than x. So that's what I'm doing over here. So if all the value of current value is less than x, then I'll be including it, and also I'll be updating the value of x. Right. So after doing this particular step, I'll be updating the answer. So answer is something, but it will be initially n. That is the maximum value that is possible is n. That is if you do the second operation for maximum number of times. Now I will just loop in from the rear side of the array. So for each and every index, so as discussed over here, so whenever we come to an element, it will be that particular element. Say let's say 2 plus the number of elements that are yet to be included. That is the second operation could be done for those particular elements. So till here, how many elements are being included? That's what this value means. So t of I plus n, that is total number of elements, minus the numbers that are included till this particular index. Right. So this is how we can solve this particular problem. So that's all about it for today. If you have any further queries or doubts, you may reach out to me in the comment section, or you may reach out to me in the social handles. And if you like this video, consider giving it a thumbs up, and do subscribe to the channel for getting the further notifications of the videos. And with that being said, it's me Sundar signing off, and goodbye. Keep coding.